Hello once again. Today's video is an introduction to our unit on circles. This photograph here was taken in about 216 miles above the Earth, and from that point you can see the curvature of the Earth. And facts about circles are going to help us understand details about the Earth, as it says there. I'm going to be giving a lot of vocabulary today and moving quite quickly. Feel free to pause this video at any point and take notes and then resume the video. All right. You'll probably remember that the definition of a circle is all the points that are equal distant from a given point within the same plane. What that means is that this radius here is the same as that radius. All of these points around the edge are all the distance of the radius away. Okay? Doesn't matter where I draw the radius. All right, the interior of the circle is the set of all points inside of circle. So we call this the interior, and the exterior is all the points outside. So it's all these points outside the green circle like this. Got a lot of vocabulary here. A chord, and this is a chord right here. AB is a chord. A chord is a line segment that starts on the edge of the circle, like at point A, and goes to another point on the edge of the circle. So it's a line segment that connects 2 points on the edges of the circle. A secant, and go ahead and copy that into your notes. A secant is a line that intersects the circle at 2 points. And you'll notice these arrows here, it keeps going on forever in that direction and an arrow forever in that direction. A tangent only intersects the circle at 1 point, and this point is called the point of tangency. We're going to learn some properties about tangents. They're really cool. The point where the tangent and the circle meet, point of tangency. Just said that. Okay. So identify each line or segment that intersects with circle L. All right, let's go find all the chords. So we've got a chord here, MJ. MJ. Got another chord that starts on the edge and goes to the edge, MK. And I think that's all for chords. A secant, a line that goes through, passes through 2 points, goes through MJ. You'll notice that on top here, we put arrows going both directions. And that, I think, is the only secant. A tangent. It looks like we've got a tangent here. It's a line which only intersects at 1 point. So we're going to call that line M. The diameter, as you know, is a chord that passes through the center of the circle. So we're going to say MK is a diameter. And the radii, we will have 3 radii here, one there, and one there. So we would call those radii LK, LJ, and LM. So you can see how we use the vocabulary to discuss different parts. Now I'm going to let you go do one right now. Go ahead and fill in all the chords, secants, tangents, diameters, radii. Press pause now, do it, and when you come back, you'll check it with my answers. So here are the answers. See if you got them right. If you haven't done it yet, don't look at this. Quickly pause it and then do it on your own. Go back a little bit. All right, let's move forward. Find the length of each radius and identify the point of tangency. Write the equation. Well, we can tell here that if the diameter is 3 for circle S, the radius is going to be half as much. So circle S radius is equal to 1.5 units. And then for here, you can see the diameter is 4. So that was circle S. Circle R has a radius. Half of 4 is 2 units. Next, identify the point of tangency. Okay, there's the point of tangency where they meet each other. So we call that point of tangency. And the value there, it looks like, is -2, 0. Finally, write the equation of the tangent line. This is the tangent line right here, okay? And you can see it falls exactly on the x-axis, which, what are we calling this equation of the tangent? the equation there is going to be y is equal to 0. And I think that's it. So you have one that you can do now. Press pause right now, and then check your answers afterward. Press pause. All right, here are the answers to the various things. The radius of the big one's 3, radius of the small one, -1. You can see the point of tangency is right here at 2, -1. And the equation of this red line, the equation of the tangent is y equals -1. All right, a common tangent is a line that is tangent to two circles. Okay, you'll notice there's a point of tangency here and a point of tangency here, and it's got another common tangent on this side. Okay, lines L and M are common external tangents to the two circles A and B. And based on that, then we have some theorems that we can go look at. Wherever a tangent meets a circle, if you draw in a radius there, it's going to be perpendicular. Okay? So the point of tangency is perpendicular to the radius at that point. And if you have a line which is perpendicular to a radius, then we know that that line is a tangent. So that's what these two things are saying. They're kind of the same thing. They're just the converse of each other. All right, here's another theorem which says if two segments of a tangent to a circle from the same external point, then the two segments are congruent. Okay, so what this is saying is the length of if they're both tangents, and they're tangent at point B and point C, then if they both start at the same external point, then those two line segments, AB and AC, are going to be congruent. So we're going to apply that here in this problem here. And indeed, it tells us that this is a tangent, HG is a tangent, and HK is a tangent. They both have the same external starting point. Therefore, this section here must be equal to that section. So we can go solve this by doing 5a minus 32 equals, and we set them equal to each other. All right, let's group everything with a on this side, everything without a on the other side, and a is equal to 12. Find HG. So HG is equal to 4 plus 2 times a, which looks like it might be 28. So that's how you would solve a problem involving this new theorem that we've just learned about tangents from an external point. So that kind of wraps up what we're doing here. We've learned about circle theorems today. We've started off our little introduction. We're going to talk next time about arcs and chords.